Okay, so today we're going to look at a technique called u-substitution, and it's a technique for taking integrals like this one here, or taking antiderivatives where it would be really tedious to multiply out x to the fifth plus 2 to the fifth. So you use u-substitution to turn these complex antiderivatives into simpler problems. So the first thing we'll do is take this x to the fifth plus 2, and we'll turn it into a simpler variable called u. So that allows us to rewrite the integral as 5x to the fourth times u to the fifth dx. So that's good. This new thing here looks simpler than the one above, but we have a couple of problems. First problem is this, that we have two variables. Now we have a u to the fifth and a 5x to the fourth, and x and u are not the same variable, and we're taking the antiderivative with respect to x. So we want to change this so that now we're taking the antiderivative with respect to u instead of with respect to x, and here's how we do that. We're going to take this equation and just flip it around, u equals x to the fifth plus 2, because that'll make it more clear what we're doing here. And we know that something about dx is just if you take the derivative of u, it's with respect to x, that's du dx, and the derivative of x to the fifth plus 2 with respect to x is 5x to the fourth. So if you take the derivative of both sides, then you have du dx equals 5x to the fourth. So what you can do now is, if you notice here, we actually have what dx is equal to relative to du and 5x to the fourth. If we rearrange this equation, then we can multiply both sides by dx and get du equals 5x to the fourth dx. And then if we divide both sides by 5x to the fourth, then we would get du over 5x to the fourth equals dx. And notice that now that we know what dx is, we can plug in for it, and let's take a look at what happens. The whole expression gets rewritten as the antiderivative of 5x to the fourth times u to the fifth, and then times du over 5x to the fourth. And what's nice about this is that you immediately notice that your 5x to the fourths would cancel, and this whole expression becomes the integral of u to the fifth du. So now we just have Okay, so that line's erased, and we are at this stage in the problem. How do we go from here? Well, the antiderivative of u to the fifth with respect to u is simply 1 over 6 u to the sixth plus c, and we take the derivative of all this to make sure that we get back to the original problem there. And the very last step is going to be to go ahead and take what we had originally set u equal to and plug it back in here, so it becomes 1 over 6 x to the fifth plus 2 to the sixth plus c. And you can notice that rather than having this really long problem of multiplying out, rather than multiplying out x to the fifth plus 2 to the fifth, repackaging it and figuring out what it would be, or setting it equal to u, made this problem a lot easier than if we had multiplied that long expression out. So let's take a look at another one of these. So what if you have something like this? The integral of 5x to the fourth minus 3 to the fourth times 20x cubed dx. Well, when you're doing u-substitution, now that we're looking at a second example, a good thing you always begin by asking yourself, what can I make u equal to make this a simpler antiderivative? And as I'm looking at this part and this part, both of these could be candidates, but you can quickly take an antiderivative or a derivative in your head, and the derivative of 5x to the fourth is going to be 20x cubed. And you know, hey, that's going to be a nice cancellation there. And let's see if that works out. So if u is equal to 5x to the fourth minus 3, then I can rewrite this as the integral of u to the fourth times 20x cubed dx. And now again we have the problem of having two different variables and also differentiate or taking the antiderivative with respect to x instead of with respect to u. So we're going to return here and go ahead and take the derivative of both sides and get du dx equals not 5, but du dx equals 20x cubed minus 0. And then if we rearrange, multiply both sides by dx, so we get du equals 20x cubed dx, and dx equals du divided by 20x cubed. That should be 20. So if we take this and plug it in for dx now, we would end up with the antiderivative of u to the fourth 20x cubed du over 20x cubed, because that's what dx was equal to, was du over 20x cubed. So you just plug that in for the dx, and now the 20x cubes cancel. This whole thing becomes the integral of u to the fourth du, which is easier to do than multiplying out that long expression in the beginning. That becomes 1/5 u to the fifth plus c, and then you can plug in what you had originally set u equal to. So originally, if you look all the way back here, u was equal to 5x to the fourth minus 3. So we're just going to rewrite this as 1 over 5x to the fourth minus 3, all to the fifth power plus c, and that's our final answer. So in this problem, again, we are starting to do the kind of du dx type thinking, u-substitution thinking. So this guy and this guy are two possible candidates for u-substitution, but if I quickly take the derivative of that, I notice, hey, that's going to be 15x squared, which will give me a nice cancellation there. So let's go ahead and make u equal to 5x cubed plus 4, because then du dx equals 15x squared plus 0, and then du would equal 15x squared dx, and dx equals du over 15x squared. So then what we can do is go back to our original equation and rewrite this as the integral 30x squared u to the 1/2, and we're going to plug in for dx and get du over 15x squared. The 15x squared cancels with 30x squared, but now this whole thing becomes 2. The 30x squared over 15x squared becomes 2 u to the 1/2 du, and the antiderivative of u to the 1/2, let's see what that's going to be. It's going to be u to the 3/2, but then I want to end up with 2 in front, so I'm going to have to make this 4 over 3. Let's see if that works. So if I take the derivative of this real quick, that would become 12 over 6 u to the 1/2, which does equal 2 u to the 1/2, so that's good. So our final answer is going to be 4/3 u to the 3/2 plus c, and then we go ahead and plug back in for u. So that's going to be 4/3 u is equal to 5x cubed plus 4, and then that to the 3/2 plus c. So this is our final answer there. Looking at this problem, we might freak out a little bit and think, oh no, there's e's and everything else in here. But again, the kind of thinking that you're doing is if I make u equal to this one, or what should I make u equal to? This one here or this other one? Well, if you make u equal to 15e to the 5x, that's not going to lead to any kind of cancellation once you plug in for dx. You're not going to get any sort of cancellation there. So I look at this one and I take the derivative quickly in my head and I say, hey, e to the 5x minus 1, the derivative of that is just e to the 5x, which will cancel nicely with that one there. So let's try this, and making all these smudges. Okay, let's try it. So if we go u is equal to e to the 5x minus 1, then du dx equals e to the 5x times 5 because of the chain rule. And then I'm just going to skip a step and go straight to what dx is equal to. And that's okay to do as long as you understand how it works. So dx would be equal to du over e to the 5e to the 5x. And now let's go ahead and make our substitutions. So we're going to substitute, this is why it's called u-substitution, because everywhere where there's e to the 5x minus 1, we're going to put a u, so it's going to be the integral of u to the negative 4th. And then we still have the times 15e to the 5x. But for dx, we're going to substitute in du over 5e to the 5x. And if we do that, then again we get some nice cancellations that happen. So what we're going to see is that this becomes the antiderivative of u to the negative 4th. 15e to the 5x divided by 5e to the 5x leaves me with a constant of 3, and all with respect to u. So the antiderivative here is u to the negative 3rd. I add 1, and then if I want a 3 constant to end up in the front, I need to put a negative there as well. And then plus c, and I take the derivative of this term just to make sure. So if I multiply the negative 3, that would become positive 3, lower the exponent by 1, that becomes negative 4, so that's good. And the very last step, we go ahead and put u back in, the x variables back in, so that's going to be negative e to the 5x minus 1 to the negative 3rd plus c. And that's our final answer. So just make sure you know these 3 examples for class tomorrow, and these are the 3 problems that we're going to have a quiz on.